Hey everyone, this is Dr. Cochran. So this is our second installment of week 13, chapter 2. So this is the metric system, something that unfortunately we have to deal with because we're the only country that doesn't use it. So in the 1970s, I think it was President Ford that said we would adopt the metric system within 10 years, and it never happened. Probably never will, because then we'd have to change so many signs, and we have plenty of other problems to deal with, changing signs being one of them. So unfortunately, English to metric is something we're going to have to deal with, and that's what everybody else in the world deals with too. So in the metric system, it's actually a nice system because it's all powers of 10. So each one of these columns represents a power of 10. We have this capital T for tera. This is 10 to the 12, so that's a trillion. We have capital G, which is giga. You probably hear about those. Even terabytes, you probably hear about in computers with hard drives nowadays. The giga, a lot of your cell phone plans are gigabyte kind of plans. We have mega, which is the size of a lot of apps you can download on your phone. Kilobytes, so maybe download speeds. Hopefully not that slow, but maybe. Here's our standard unit, which can be lots of different things. It can be the meter, which is what we use for distance. The liter, which we use for volume. The gram, which we use for mass. It could be calories for maybe energy. Seconds, the list goes on and on. This is our 1, so it stands for 1, meaning it's our standard unit. It's a standalone unit, represents 1, whereas say this one represents 1,000. This would be a million. So you hear about things on the news like mega millions. This is where they get it from for lotteries. Giga would be a billion, and then tera would be a trillion. So if we go in that opposite direction, you're going to see that the first 3 are mentioned. Our textbook doesn't mention the hecto and deca that are in the between the kilos, so we're not going to worry about those. But deci is a tenth, so 0.1, or in scientific notation, 10 to the negative 1. And that's lowercase d. Lowercase c is for centi, so that's a hundredth, or 10 to the negative 2. Milli, lowercase m, the only capital letters were these very big ones. This is 1,000, so 10 to the negative 3 is the power of 10, but it's also 3 positions back from the decimal. And then micro is the only weird one because micro is what you'll see in, say, microbiology. It's 10 to the negative 6, that's a millionth. It's a Greek letter, looks like a U with a long tail on the left. It's called the mu letter in Greek. Nano, this is about the size of an atom. Nanometers is the length of bonds. In a lot of cases, are angstroms sometimes used as well. So this would be a billionth, 10 to the negative 9. And then pico to 10 to the negative 12. So trillion. So we have trillion, trillionth, billion, billionth, million, millionth. And then we have that thousands, and then 1,000th, and then the hundredths, tenths, and then the actual standard unit. So our numbers typically that we see in chemistry are in this column here. And everything else gets bigger or smaller based on that. So what I like to do with metric numbers is use this ruler, much like the one in experiment 20, and just adjust the number, not worry about any kind of conversion process and unit cancellation process specifically for the metric system. So I'm just going to do a couple examples of how this would work. So let's say we want to, I'm going to use this extra sheet of paper so that I don't have to erase or anything like that with a Sharpie. So let's say that we have a number like 250 millimeters. So notice I put the 250, it stopped in this milli kind of category. So this would be 250 millimeters if this were asked on, say, a homework question. If they say, what is this in micrometers? So if you want to go to micrometers, we would just take the decimal from here, move it to the edge of micro. So no longer here. And then notice each column is just another 0. So this would just be 250,000 micrometers. So very fast way to convert to the metric system just by moving your decimal on this little slide ruler kind of scale. So we can do this with anything. Let's say you're a nurse and you're using deciliters or something like that. So maybe you have 15 deciliters, so 15 D capital L. But for whatever reason, we need to know how many milliliters that is. So if we want to go to milliliters, we would just move the decimal from that imaginary right side edge of deci over to the right side edge of milli, and that would just add 2 zeros, so 1500 milliliters. We could also go in the opposite direction. Let's say in your cell phone plan, you have a 20 gigabyte plan. So 20 imaginary decimal on that right side edge. If you want to know how many kilobytes that is because you're downloading, streaming videos, Netflix, whatever, we're going to have to move that to that right side edge. So even those big units can do the same thing, just add 1 0 per column until you get there, and now you have 20 million. So this would be like if we wanted to go from 20 gigameters, or in this case gigabytes, I guess, to kilobytes, and notice we'd have now the decimal is now here, no longer here. So 1, 2, 3, 4, 5, 6, 7 zeros. So 1, 2, 3, 4, 5, 6, 7. So comma, comma. There's our 20 million kilobytes. So everything there we've added zeros to. But now let's try an example where we go smaller. So maybe we have, let's say an ant is 8.5 millimeters. So this would be a number 8.5 millimeters on the chart, but let's say we want to go to, for whatever weird reason, meters. So what kind of number is this in meters? Well, just like before, take your decimal in that right side location, move it to your new unit, which is the standard unit of meters over here, and you can add zeros here. So because this is a much larger unit, you're going to get to a smaller number, so it'd be 0.0085. Notice there's 2 zeros between the decimal and the 8. 2 zeros between the decimal and the 8. So meters. So either way in the metric system you can go right or left, and that makes conversion of the metric system very easy if you have a metric ruler and if you know the powers of 10 to get you there. A fun way to learn the metric system is just to know the letters in order. So for this one we can say that Terry, for capital T, G for got, mad, kicked, for K. We can use the meter, which is very common for my, D for dog, chased, milli, let's pretend that's a person, M. Mu is the letter in the Greek alphabet, so let's just say mule. So there's the MU for mu in the Greek alphabet for mule. Because that's weird, notify the police. So there's a fun way to know the letters. TGM, K, M for the standard unit of meter, D, C, little m, mu, which is the weird Greek letter mu. Notify police is a fun way to know those. So if you know them, most of them are 3 powers of 10 apart. Just know that this section here, those are 1 apart. And that's the metric system in a nutshell. So you still have to deal with things like going to the English system. So here's 3 fun facts about English to metric. So for every 1 inch, that's 2.54 centimeters exactly. So this is technically 3 sig figs, which is important, but this is also exact, so it's kind of irrelevant in that sense. 1 pound is 454 grams. So if you know the variations in pounds, whether it's in ounces or tons or whatever, you can go back to grams, eventually to kilograms using the table. Just like with inches and centimeters, if you wanted to go from your height in inches to meters, you could go to centimeters, but then use the table to go back up to meters, and vice versa. And then lastly, if you wanted a volume, you could use 1 quart is 946 milliliters. So anything in the metric system, once you have milliliters, you can scale it. But if you know a little bit about the English system that hopefully you learned all throughout middle school and maybe high school, you hopefully know how many pints are in a quart or quarts are in a gallon, that kind of idea, to get you up and down the English scale. So as we learn these, just know that we're expecting you to know the English system. We're expecting you to know how to deal with inches and feet and yards and miles and so forth. But we're teaching you the metric system because unless you're an exchange student on some athletic team in a lot of situations with our students, you probably don't know much about the metric system without covering it in class first. So hopefully this gives you a handle on how to convert, and it's really just using this, putting your number in, and then readjusting the decimal place either right or left to get you to some of those numbers. So we'll catch you next time with some conversion practice.